Hi everyone, so in the previous video we learned about enthalpy change. We learned how to solve for a enthalpy change of a chemical reaction. So please check the previous video first before jumping here. So we also have a term called standard enthalpy change. So when we say standard, it means that we have conditions. We know that in enthalpy change, it is the change of heat of a given chemical reaction at constant pressure. While when we're talking about standard enthalpy change, or the standard enthalpy of formation, is defined as the change in enthalpy when 1 mole of a substance is in the standard state. So this is the condition. So when we say standard enthalpy change, it is defined as the change in enthalpy when 1 mole of a substance is in the standard state. So the standard state of a substance is specified as its true form at 1 atmospheric pressure and at temperature 25 degrees Celsius or 298 Kelvin. So when we say standard enthalpy change, instead of delta H, we have delta H with a superscript 0. This is how we denote the standard enthalpy change. Enthalpy change is just delta H, but when we say standard enthalpy change, we have this symbol. So when we say standard, its pure form is at 1 atmospheric pressure, 1 atm, and the temperature is at 25 degrees Celsius or 298 Kelvin. So we have a standard condition. So if you can recall your STP and non-STP stoichiometry lesson, that would be helpful. So the standard enthalpy of formation is a measure of energy released or consumed when 1 mole of a substance is created under standard conditions of its pure elements. So this basically sums up what the standard enthalpy change is. So the triangle or delta indicates the change of enthalpy. The degrees or the superscript circle signifies that it's a standard enthalpy change. Okay, it's standard. And the F indicates the substance is former of its elements. Okay, former of its elements. So we'll get to know more about this symbol when we know the equation. So the equation for the standard enthalpy change is this one. The standard enthalpy change reaction is equal to the sum times the sum of all of this times n, and standard enthalpy of products minus the sum of this one times n, and the standard enthalpy of the reactants. So n here is our number of moles. So we have to remember a few notes, and since the value of enthalpy change depends on the conditions of temperature and pressure, so standard enthalpy depends on the temperature and pressure as well as physical states. A set of conditions called standard state is specified for thermochemical data. So these conditions are: number 1, the standard enthalpy of formation, this one, It can be this one or this one with the F, meaning former of its from its element. Is the change in enthalpy for a reaction that forms 1 mole of a compound from its stable elements and at standard states. The enthalpy of formation of the most stable form of any element at 1 atm and 25 degrees Celsius is 0. So before we continue to solve, we must identify which element or compounds or elements are in its stable form, most stable form. So for example of a stable form of oxygen is O2. O2 is the most stable form of oxygen. This is oxygen gas. It's not O3 and it's also not O. So the most stable form of oxygen is O2. The same goes for nitrogen gas. It's N2. For hydrogen gas, it's H2. This is the most stable form of nitrogen. It's N2. And this is for the hydrogen. This is the most stable form. So not all elements have its most stable form, only the selected ones. So if you want to make sure which is or what is the most stable form of an element, you can use the internet for this. So the second we want to note is that the standard enthalpy of reaction is the enthalpy change when all the reactants and products are in their standard states. The standard state of a material is a reference point used to calculate its properties under different conditions. Okay, so by definition, the enthalpy formation of the most stable form of an element at 1 atm and 25 degrees Celsius is 0. So when we encounter oxygen gas or any stable form, the enthalpy change is automatically equal to 0 for that element. Okay? So for aluminum, we have it's all Al in solid. Now this is 0, the enthalpy change of 0 and 0. And for bromine or dibromide, it's 0. And the standard states of other stable elements are all equal to 0. So other stable elements, you want to identify these first. So let's say that we have an example. Let me check first. So this is a given problem. So we are asked to calculate the standard enthalpy change for the reaction, for this reaction. And we have this given enthalpy, standard enthalpy change per compound. Okay, so notice that the O2 enthalpy change here is not given because it is automatically 0, because O2 here is at its standard, the element here is its standard or purest most stable form. Okay, so we use the given formula. The solution for this is pretty much given. we have the formula delta H standard. We have the summation of n products minus delta n reactants. So now we know that this one and this one are in, reactants, but we're looking for the products first in the first term. So our product would be CO2 and H2O, this one and this one. So now we have the coefficient for CO2. We have 2 times negative 393.5 kJ per mole plus 4 the coefficient of H2O times its standard enthalpy change, which is negative 285.8 kJ per mole. And that's all we have for the product side. And then we have the reactant side, which is 2 times the given for enthalpy change given for CH3OH, have negative 238, negative 238.7 kJ per mole, plus I know that we have an oxygen in the product side. I just want to show you that it is 3, the coefficient for O2 times, since it's stable, O2 is its most stable form of oxygen, the enthalpy change is 0. So this is automatically 0. Now use your calculators here, and by the end of it we should get 1452.8 kJ per mole. So this is our enthalpy change, standard enthalpy change for this reaction. 2CH3OH plus 3O2, 2CO2 plus 4H2O. This is what you need. This is the energy needed for that reaction to occur.